This week we're heading into space to find out how we'll live, work and eat on the moon. We have space homes and a space woman.
All of a sudden it clicked in my head, wow, the International Space Station has a submarine in space.
Moonbots and moon dust.
Surface is fine and powdery. I can pick it up loosely with my toe.
You know, I think I've seen that chap somewhere before.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
It's one small step for man, one giant leap for mankind.
52 years ago, we laid our last footprint on the moon. As the crew of Apollo 17 left the surface, they didn't know that Gene Cernan would be the last person to walk on another world for quite a while.
Run away, Houston.
But now, in this decade, finally, we're going back.
And liftoff of Artemis 1.
NASA's Artemis program will, in the next year or two, return us to our neighbour. Part of its mission to land the first woman and the first person of colour on the moon. Another part, to use what we learn here to send the first astronauts to Mars. This is where it all began. Florida's Kennedy Space Center, named after the president who made the original pledge to go to the moon. And now this place is at the center of even grander plans. Because this time, we're not just visiting the moon, we want to stay. This is Gateway, humanity's first space station that will orbit another world. It will go round the moon every 7 days. And like the International Space Station above Earth, astronauts will call this place home. Although where the ISS can accommodate up to 12 astronauts and is comparable to a 5 or 6 bedroom house, Gateway will be more cosy.
Gateway is a studio apartment. We're going to have room for our 4 astronauts, multiple docking ports so we can bring our Orion crew transportation ship, we can bring logistics, and we can dock a lander.
These 4 explorers won't all be cooped up on board for the whole time though. 2 will actually be spending a week or 2 on location, down on the lunar surface. It's a chance to further study the landscape and hopefully find a location for our next giant leap, a permanent moon base.
Gateway will be there before we put a habitat on the surface. Gateway allows us to access any point on the lunar surface. When we went with Apollo, we had to pick that spot on the moon and go to it. Gateway will give us the opportunity to go down at different locations.
The first section of Gateway could be launched as early as 2025, with new modules then being added from 2027. A lunar base is admittedly further out, and it comes with risk, but also reward. So how do we make that a reality? To find out, it's time for me to take one small step of my own. Oh wow, I can instantly see the dust kind of kicking up.
Yeah.
It's really fine, isn't it?
It leaves the footprints like you'd expect.
Oh my gosh, that's brilliant. And this is how moon dust behaves, it just like
It
puffs
does,
up like
yeah,
that.
yeah, it's so fine.
Welcome to Swamp Works, the dusty, dirty lab where they work with simulated moon dust. Now, the loose soil that covers the lunar surface is called regolith. It's extremely fine, very sharp on a microscopic scale, and it gets everywhere.
So when we landed with Apollo 11, We didn't know what the surface of the moon exactly was going to be like. You'll notice from some of the footage the landing pads are quite huge on the landing legs, and the ladder is far away from the surface, right? There was a lot of concern of how much will this lander sink into the surface? How fluffy is this regolith?
Surface is fine and powdery. I can pick it up loosely with my toe.
In fact, it's because the Eagle lander didn't sink in as much as expected that Neil Armstrong had to take such a giant leap from the bottom rung of the ladder. Today, SwampWorks is developing robots that can cope with and take advantage of lunar soil. And it will be very useful. See, moon dust is made of materials like silicon dioxide and calcium oxide, which all contain a lot of oxygen. If we could mine the regolith and use chemical processes to extract the oxygen, we could make our own breathable air and our own rocket fuel.
The way spaceflight exploration has been working right now is, imagine you're going on a holiday with your family, you're going on a long road trip, thousands of miles, right? Right now we are bringing a trailer behind us with all the gas, all the, that we need with us, all the fuel, everything that we need comes with us, right? So we want to change that paradigm. We want to, and one of the biggest things that makes the biggest impact is the fuel, right? If we can source some of that from the moon and eventually from Mars, that will allow us to bring more and to go more often.
Making our own fuel makes regular trips to and from the Gateway Space Station much more viable. Now, mining moon dust is called ISRU, In Situ Resource Utilization. And because they love an acronym around these parts, the robot to do this will be called the ISRU Pilot Excavator, IPEX.
We had to really reinvent how you do excavation for doing mining on the moon and eventually Mars. The challenge is the technology we have for mining here on Earth relies on a lot of mass and a lot of weight, right? The more steel you put on an excavator, the heavier it becomes and the better it digs. We can't launch something as heavy as we want on a rocket. It's still very expensive, right? So we have to reduce the mass of what we put on rockets, and then when you land it on the moon, it weighs 1/6 of what it does here on Earth, right? Imagine like trying to dig as if you're on ice, right? It just, scoot across the surface, the scoop will not engage, and you won't be able to collect anything.
So the way the robot scoops up the dust is using this thing called a bucket drum, and it's got a kind of spiral in there. And if it turns it one way, it scoops the soil, which gradually works its way towards the middle and stays there. Like that. And then when it wants to unload, it turns it the other way, and it all comes out again.
We put them on opposite ends of the robot, and when it excavates, it's using both sets of drums at the same time, but they're digging in opposite directions.
So one is pulling it that way, and one is pulling it that way,
Right.
and pulling itself down to the surface.
Yeah.
One of the main dangers faced by extraterrestrial rovers is getting stuck. So as an added bonus, IPEX's scoops and arms can also help it to get out of a hole or flip it over if it takes a tumble. One of its other defences will keep its cameras free from all that electrostatic dust, which will cling to every part of it. Its lenses will be fitted with an electrodynamic dust shield. Simply apply electricity and the charged dust particles are repelled, keeping its vision clear. But after a while of going to and fro, we might want to stay a little longer on the surface. Robots like this one will prepare the ground for permanent buildings by smoothing and compacting the foundations.
Do you have a name for this arm?
We call it Meerkat, actually.
You've always got cool names for these things.
Yeah.
Why?
It's called the multi-purpose end effector for regolith acquisition, Meerkat, transportation, and yeah, that's it.
You see, what worries me is there are some brilliant inventions you guys haven't bothered with because you couldn't think of a cool
Can't think of the cool
acronym.
name. That is like one of the. It's very important to have a good name for your projects because it like represents the soul of the project, right?
Now, just like the fuel situation, we can't take building materials with us to the moon either. We have to make our structures from moon dust. These bricks and blocks and bars have all been made by mixing and melting regolith with plastic. In the future, giant 3D printers will build shelters to protect those living on a world with no atmosphere from radiation, asteroid and micrometeoroid impacts, moonquakes, and temperatures ranging from plus 100 to minus 200 degrees Celsius. Even replacement parts can be made from regolith.
So this is a wheel that has been printed with regolith and polymer.
Okay.
So this is another example of what we can do if we capture the resources from the moon.
Now, do you know, I've seen and held wheels for rovers before, full-size wheels, and they're really light.
Right.
But this is really heavy.
Yes, this is the opposite, right? Because those wheels that are light, especially if you're sending it on a rocket, they need to be light because it's expensive. This is heavy because it's made on the moon.
And heavy wheels are a good thing, I guess.
It's better,
especially
right?
for a digger like that.
Yeah, the more weight that we have on the excavator, the better it's going to perform.
Would you believe you can even make rope out of regolith? This is made from basalt glass, really, really thin fibres, a bit like optic fibre. So you can even make rope out of moon dust.
These are hopeful times for space exploration, but it's always been a risky endeavour.
IM-1, Odysseus lunar lander, separation confirmed.
This year we've seen 3 probes sent to the moon. 2 made it, and both of those had, shall we say, awkward landings. And the Artemis mission to put boots back on the lunar ground has been pushed back to 2026 at the earliest. But NASA says space explorers need to take these setbacks in their stride.
I don't see it as a disappointment. It's very cliche to say space is hard, but what we're endeavoring to do is highly complex. We expect challenges along the way, so this doesn't surprise us, and we're pushing forward.
It sounds really expensive to do space exploration. Is it, and is it worth it?
So yes, it's really expensive. It was really expensive for us to explore this planet. Really expensive to lay rail infrastructure, to lay highway infrastructure, to put the infrastructure in place that allows us to travel in air traffic around this globe. It's absolutely necessary for us to lay that critical infrastructure for going to space, because what we learn in that endeavor is tremendous. The exponential growth that we've seen in the world in technology is because of great endeavors like this. It's absolutely worth it. Here in the United States, every year, the general population is spending as much money on potato chips as our budget is every year to go out to the moon.
That's a good figure.
The motivation may be different to that of the space race of the 1960s, but the size of the ambition is just as great today as we shoot for the moon once again.